this lesson is our first lesson in Chapter 8, and Chapter 8 is all about similarity. We're going to talk specifically about similar polygons, and similar polygons have the same shape, but not necessarily the same size. So one is usually going to be larger than the other one, but they do always have congruent angles. You notice in the triangles that angle A is congruent to angle D, and angle B is congruent to E, and C is congruent to F. So we know that they have congruent angles, and we'll also talk more about how their corresponding sides are proportional. And you've talked a little bit about that in the last couple of years of math, and we'll get into that a little more as we move into the chapter. We're going to start out with 8.1, which is dilations. So a dilation is something that makes the shape get larger or smaller. And you'll notice for this example, the pre-image is the small triangle A, and the new image is A prime. And there's a scale factor of 2. That means that if the length of this side is A, then the length of this side would be 2 times as long as A. So a little bit of vocabulary here. The pre-image is the original figure, and that's always denoted with something like just A, B, P, whatever. There's no extra markings on it. The image is the new transformed figure, and so that's going to be A prime or B prime. That's when you see this apostrophe, we say the word prime. So that is A prime. And then the scale factor that you saw mentioned in the picture, that's the ratio of the new to the old. So for this one, the new length of this side is 2A, so the scale factor would be 2A over the original length, which was A, and we know that then our A's would cancel out, so this has a scale factor of 2, and we're going to practice that as we go through this section. So as I said, dilations make things larger or smaller. So if it makes something larger, it's called an enlargement. And so we see our pre-image is this small pentagon, and the new image, A prime, is the larger pentagon. The second example is a reduction. We start with the large triangle, which is the pre-image, and it becomes a smaller triangle, A prime, and so that's considered a reduction. Now, a dilation is a transformation in which the figure is enlarged or reduced with respect to a fixed point C. So that fixed point C is called the center of dilation. And I want to address the center of dilation first. The way we can find the center of dilation is if we connect the corresponding vertices to each other and extend the lines. When I connect those vertices, you'll notice that all 3 of those lines intersect at this point right here. That point C is considered the center of dilation. And the scale factor is K. So remember I said that scale factor is always found by taking the new and putting it over the old or the original. So for this one, A prime is actually the smaller triangle. So the new side is 7 and its corresponding side is 10. So the scale factor is 7/10. You'll notice that since the scale factor is less than 1, this was a reduction. The shape got smaller. So here are a few examples which give us an opportunity to decide whether or not it's an enlargement or a reduction. If we look at this first example, the original shape, that would be the one that has P. That's this shape right here. And P prime, you can see here, is smaller. So we know that this one is definitely a reduction. Oh, that's lovely handwriting. It's a reduction. And then to get the scale factor, remember we do new over old. So the new length, well, let's see. This length from here to here is 4. This is 2, which means this is also 2. So this is our new 2 over our original distance here, which is 4, which is 1/2. You'll notice on this one, we use the distance to the center of dilation instead of the lengths of the sides. You can find the scale factor either way, either by using the lengths, like say this was 8 and this was 4. We could use those numbers to get 1/2, or we can use the distance that corresponding points are to that center of dilation. So if you look at this one here, P, the original point, is how far the center of dilation actually happens to be on the figure. In this one, the center of dilation is C. That distance is 20. The new distance is from C all the way to P prime. That's 25. So we'll notice that this shape got larger, so that's an enlargement. And then to get the scale factor, we're going to do the new length, which is 25, over the original, which is 20. And if you want, you can make that a decimal if you like. I'm probably just going to reduce it to a fraction and leave it 5/4. The scale factor is 5/4. Now the last example here, here's our original shape. That's the one that has the P. And so it's the little one, and the new one is the large one. So this is another enlargement. And you'll notice for this one, the center of dilation is actually in the middle of the shape. So it could be outside the shape like it was in this first example. It could be one of the points on the shape, like the second example, or it could be inside the shape where it is on this last example. And then to get the scale factor, we're going to do the new length. That's from C all the way to P prime, so that's 27, over the distance from C just to P, which is 9, so the scale factor is 3. So this one is an enlargement with a scale factor of 3. Okay, now the next thing we're going to talk about is the coordinate rule for dilations when they are centered at the origin with a scale factor of k. So for these, our C, our center of dilation for all of these is going to be the 0.00 when we're talking about this rule. And the scale factor is k, so that could be 2, it could be 1/2, it could be a negative number, it could be something like -3, that's fine. The original point is going to be xy. The image, the new point, is going to be k times x and k times y. So when we do something like graph the pre-image of ABC and then the image of A prime, B prime, C prime. Well, for this it says our scale factor is 2. So we're going to take 2 and we're going to multiply 2 times every x and 2 times every y to get our new points. So if point A is -3, 1, A prime is going to be -3 times 2, which is -6. And 1 times 2 is 2. And then we're going to take B and we're going to multiply both of those by 2. So we're going to get -8, -2. And then for the last one, -2, -1, we're going to multiply both of those by 2 and get -4, -2. And they've asked us to graph both. So I'll graph ABC first. So -3, 1, and I'm going to label it A. -4, -1 is B, and C is -2, -1. I'm going to go ahead and sketch that. And then we'll graph these three. -6, +2 is going to be A prime. -8, -2 is B prime. And then C prime is -4, -2. And I can connect those. And so that's my new shape. We see that it is an enlargement. It's got a scale factor of 2. Now I wanted to show you on this one, this scale factor is a fraction. So when the scale factor is a fraction, we saw that earlier, it's going to make it a reduction. And the scale factor is also a negative. And that's okay. So we're going to take A, B, and C, and we're going to multiply them all by -1/2. So A prime, multiply 0 and 4 by -1/2. That's going to give us 0, -2. B prime, multiply both of those by a negative, so we get -2, -1. And for C prime, let's fix that one. C prime, 2 times -1/2 is -1. -2 times -1/2 is +1. And then we'll go ahead and graph both. So the original was, oops, let's see. Our graph got moved just a little bit. Okay. All right, A is 0, 4. B is 4, 2. And C is 2, -2. So this is our original triangle. And then we'll graph, so that's the pre-image. And then the image, A prime is 0, -2, -2, -1, and -1, 1. So that's A prime, C prime, oh, B prime, whoops, and C prime. And that's our new dilation. That's our new shape. Okay, a couple extra problems that you're going to see, things, just a real life example type thing. You design a poster on 8.5 by 11 inch paper for a contest at your school. The poster winner will be printed on 34 inch by 44 inch canvas to be displayed. So what's the scale factor of this dilation? Well, I went ahead and started with a little sketch of a little picture of a notebook paper. And so this would be the 8.5 and this would be the 11. And then the enlargement, right, is going to be 34. Obviously, this isn't to scale, by 44. Well, to find the scale factor, remember we do new over old. So we're going to put this one over this one. We can either do 44 over 11. Oops, 44 over 11. Or we could use the width and do 34 over 8.5. Well, I think you can see that the 44 over 11 is going to be easier either way, but our scale factor is going to be 4. The new canvas is going to be 4 times the size of the original one. Okay, the second example says we have a biology book, and the biology book shows an image of an insect that is actually 10 times its actual size. So this insect that we're seeing is 10 times what the insect would normally look like. And the image of the insect, this picture that's in the book, is 8 centimeters long. So this is 8 centimeters long. Well, it's 10 times bigger. So this number is actually 10 times larger than it ought to be. So in order to get the actual length of the insect, we're going to take that 8 centimeters and divide by 10. And so the actual length of well, for this it's a bee, but the insect would be, if we wanted to do decimals, 0.8 centimeters. That's the actual length of the insect. All right, and that's all we're going to say about dilations.